All right, guys, so day 3, we're going to be solving multi-step equations. This is kind of combining what we did in 1-1 with 1-2 and pulling it all together. We are actually going to be solving these for x today. It's my primary variable we're going to be using. So our answers will be x equals a number, a fraction, things like that. The thing is, we're going to have to distribute like we did in 1-2, combine like terms, and then go back to what we did on 1-1, which is get our variables all on one side, our numbers on the other, and solve. So let's just jump right in and look at number 1. I've got 4 times x minus 3 equals negative 2 times 9 minus 8x. So let's just start off like we did the other day. Let's do our distribution. First, I have 4 times x minus 3, so 4 times x is 4x. Then I have 4 times negative 3 is negative 12. So that's all I have to do on that side. Equals, and another distribution, negative 2 times 9 minus 8x. Well, negative 2 times 9 is negative 18. Negative 2 times negative 8x is plus 16x. So it's really not that bad of a problem so far. Watch your multiplication, okay? Don't assume you know something if you're not 100% sure. Do whatever you have to do to get that right. Now, the next step, what we would have done on distribution is combine like terms. Well, guys, we can't combine like terms unless they're on the same side of the equal sign, okay? So the 4x minus 12 and the negative 18 plus 16x, I can combine terms across there. So there's nothing to fix on either side. Now I'm going to start moving things around. Now remember, when we're solving these equations and moving things, if you do something to one side, you have to do it to the other. And right now, I want to get 4x off of the left side. I want to move it to the right side. So to do that, I'm going to subtract 4x from both sides. Well, 4x minus 4x cancels that side out, which is what I wanted. Now all I have is negative 12. The negative 18 can't be combined with anything x's, but 16x minus 4x gives me plus 12x. Now all my variables are on one side. Let's get our numbers on one side. I want to move the negative 18 to the other side. Yeah, I could move the negative 12, but then I'd have 0 still left on one side. And remember, we want numbers on one side of the equal sign, variables on the other. So I'm going to add 18 to both sides. Negative 12 plus 18 will give me 6. Negative 18 plus 18 makes those cancel out. All I have left is 12x. Now we have to finish solving for x. 12 is attached to x through multiplication, so that means we're going to use division to undo it. I'm going to divide by everything but my variable. Now on this side I have 6 over 12, but I can simplify that. 6 over 12 is the same as 1/2. The 12s cancel each other out, and I'm left with x equals 1/2. And that's all there is to it. So it's just a big smash up of what we've been doing the last few days. Take your time, watch your addition, subtraction, multiplication, and division, and this really isn't hard. But if you go fast through this, you're going to mess things up. Fractions are okay to get as answers, okay? We don't need to be scared of them. Now let's move on to the next one. This one looks a little bit longer, but it's no harder. 5 times 3x minus 18 equals 30 minus 4 times 6x minus 9. The first thing we want to look at is our distribution. So I have 5 times 3x. 5 times 3 is 15 with an x. 5 times negative 18 is negative 90. And guys, if you need to use your calculator for that, use it. You'll have it on the STAR test, so use it as much as you can. Now that's all we have on that side. On the other side, I have this 30 that has nothing to do with distribution. And now I need to distribute my negative 4. Negative 4 times 6x is negative 24x. Negative 4 times negative 9 is plus 36. So distribution is done, guys. I'm going to look at the left side of the equal sign first, and I notice there's nothing that I can combine. I'm going to look at the right side, and I notice that there is. So I'm going to go ahead and write this 15x minus 90 since it didn't change. But if I look over here, I have 30 plus 36. So I'm going to have 30 plus 36 is 66, then minus 24x. Okay, so that's exactly what we did in 1-2. Now we need to change gears and solve for x. So there's a couple of steps you could do to solve this. And you may not think while you're working them that, oh, my order is exactly what you were going to do, but I like to keep my variables positive if I can. So if I subtracted 15x from both sides, I'd have negative 24 plus or minus 15. I'm going to add the 24x to both sides. Now you could move that 15, that's just fine. You'll end up with the same answer, your work will just look a little different. So let's see, 15x plus 24x will give me, how about 39x, not 29. The 90 doesn't change. And that equals just 66. Negative 24 plus 24 cancels out. Now, I need to move my negative 90 to the other side by adding it to both sides. So that leaves 39x. Negative 90 plus 90 cancels out. And now I have 66 plus 90 is 156. So we've taken care of everything we can except for some division. 39 times x equals 156 means I have to divide both sides by 39. And when you do that, it comes out to x equals 4. The 39s would cancel. You can put that in your calculator to get the answer. Okay? So, guys, these have a few more steps, but there's going to be less of them. So you're really not doing a whole lot more work. You just have to be careful. Watch your arithmetic. Let's go on to the next one. So basically the same types of problems, guys. I have 5 times 2x minus 3 equals 3 times 3x minus 5. We're going to go through this one kind of quick because it's pretty easy. So I'm going to work my distribution first. 5 times 2x gives me 10x. 5 times negative 3 is negative 15. I move to the other side of the equal sign. 3 times 3x is 9x. 3 times negative 5 is negative 15. So I'm looking at both sides of the equal sign. I see nothing that can be combined. So I'm going to start moving my x's. I'm going to subtract 9x from both sides. You could subtract 10x from both sides. You'll have negative x, but you'll still come at the same answer at the end. 10x minus 9x leaves me with just 1x, or x, minus 15. 9x minus 9x cancels and leaves me with minus 15. Now we just need to get x by itself when we're finished. I have x minus 15, so to get rid of the minus 15, I have to add 15 to both sides. I have x left on this side. The 15's canceled. And negative 15 plus 15 gives me 0. So guys, getting 0 is perfectly fine. You can have answers where x equals 0, so don't panic if that happens. So our answer on this one is 0. Let's move on to number 4. Now, I would say that of the first page, this one looks like it's the hardest, but it's just because of a fraction, and our fractions are easy to get rid of, so don't panic when you see one. It looks like on the left side, there's nothing I can do. There is no distribution, so I'm going to leave it alone. But on the next one, I have 5 times 9/5 minus x. So let's go ahead and distribute. Now I'm going to write a little something over to the side. This is really 5 times 9 over 5. Okay? Now, when we do this, this is kind of like the numerator of this fraction. This is the denominator. That's why they will cancel out, okay? So what's left is really 9 over 1, which is just 9. And that's what we were doing the other day when we canceled out fractions. When you multiply by the denominator, it leaves the numerator. So what I end up with is just 9. 5 times negative x is negative 5x. So guys, we had a fraction. It looks scary, but after one little step, it's gone, and now everything looks better. There's no combining like terms that I can see. So I'm going to go ahead and move, well, it doesn't really matter which one I move. I'm going to move my 5x. I'm going to have to add it to one side or the other. And that's a little weird on this one because both sides had the same amount of variables. And if you notice, I have 9 left over here in the 5x's cancel. And on the other side, 9 there, and the 5x's cancel again. What I got was something strange. This is a true statement. 9 does equal 9. That is absolutely true. Now, 9 wouldn't have equaled 8, but 9 equals 9. So this is a true statement. We've got a little writing here. This is a true statement. Statements where the variables cancel out, guys, are true. Therefore, the answer is all real numbers. And guys, there's a symbol for all real numbers. If you want to write it out, that's perfectly fine. But the answer is all real numbers. Let me explain why. If you go back up to this line right here, the equations are exactly the same on both sides. 9x or 9 minus 5x and 9 minus 5x. Well, it makes sense that any number I plug in for x there would make it work since they're exactly the same equation. So if you end up with something where the variables cancel out, that's perfectly fine. You're going to have a true statement if they equal each other, and the answer is all real numbers. Okay? Now, there's another way this can happen we're going to look at in a second. So if it's a true statement, it's all real numbers. Let's look at the next one. Go to the next page. Just a couple more, guys. Now, again, looking at number 5, you might get a little scared because of fractions, and there's going to be a fraction that's running around in this. So let's go ahead and do our distribution, guys. Sorry, I got interrupted a little bit there. So I have 2/3 times 3x minus 5. So I have to distribute a fraction this time, and it can be a little more confusing. I'm going to write something up over here. I have 2/3 times 3x. I'm going to go ahead and put it over 1 because that's really what it is. Well, guys, these 3's cancel out. What's left on the top is 2x over 1. Now, we know we don't have to write that 1, so there's the product. Now I have 2/3 times negative 5 over 1. Well, the 5's will cancel, but the negative didn't. All right, guys, scratch that. I see what I did there. Let me see if I can go back here. I wrote 2/5, not 2/3. I was wondering what was going on. It's 2/3 times negative 5 over 1. Now, we don't have anything that's going to cancel this time. When you multiply fractions, you do numerator times numerator. 2 times negative 5 is negative 10. Then denominator times denominator. 3 times 1 is 3. Now, there's nothing we can do there. We don't want to turn it into a decimal, so I'm just going to write minus 10 over 3. Now, that's probably the hardest thing in this problem. If you have problems with fractions, come ask. We can go over fractions in a few minutes, and you'll be perfectly good. But if you don't ask, you're never going to find out. Then I have equals 2x plus 7. No distribution needed. So now, guys, I know there's a fraction, but big deal. Let's worry about variables first. It looks like no matter which side I move, I'm going to have to subtract 2x. So I'm going to do that to both sides. Well, 2x minus 2x cancels. Leaves me negative 10/3 equals 2x minus 2x cancels and says it equals 7. Now, I hope that y'all can look at this and know negative 10 over 3 is not equal to 7. That's not going to work. This is false. Now, you should be able to tell just because one's negative and one's positive that that's not right. And if you get there, that's okay. There's a solution when it's false. So I'm going to write below a couple more things. This is a false statement. The variables canceled out and the numbers that were left did not work. So it's a false statement. Therefore, the answer is this. It's a 0 with a line through it, which means no solution. That means that there's nothing I can put in to make that work, okay? So you have, when the variables canceled out and the numbers equaled each other, you had a true statement. It was all real numbers. But when the same thing happens and the numbers left don't equal, you have a false statement, which is no solution. All right, guys, we're going to have to think back a little bit. This problem number 6 can be a little bit challenging. It's 3x over 4 minus x over 3 equals 10. We've got two fractions rolling around. Now earlier I've told you that multiplying by denominators will get rid of fractions, but in this one, both fractions have a different denominator, so just using 4 or 3 won't work. It'll actually make things a little more complicated. What you're going to have to look for, and I'm going to write this over here, is a common denominator. Okay? And what we probably want is the least common denominator, the first number bigger than 4 or 3 that both those numbers will divide into. Now, I would tell you, probably the quickest, easiest way to get a common denominator is take your denominators and multiply them together. If I do 4 times 3, I get the number 12. So if I multiply both sides of this by 12, the fraction should go away and I'm left with something a lot easier, okay? So I'm going to kind of do this the long way. I have 12 times 3x over 4. If I take 12 and if I take 12 and divide it by 4, I get 3. So what I'm going to do, let me just do this the long way. I think it'll be less confusing. So 12 times 3 is 36. So I have 36x over 4. But then I have to distribute it here as well. So I have minus 12 times x is 12x over 3 equals 10 times 12, 120. Okay, sorry I stumbled over myself there a second ago. If you need help with this, just ask. Well, it still looks like I have fractions, but now look at the numbers. The numerator in each can be divided by the denominator in each. Well, 36 divided by 4 is 9, and I have an x, minus 12 divided by 3 is 4, and I have an x, equals 120. Now that is a lot better. You may be able to skip that middle step right here. If you can, go ahead. If you can't, use that. I mean, it's nice to see, and you can put it in your calculator. Well, 9x minus 4x can be combined to get 5x equals 120. And then I divide both sides by 5 to undo the multiplication. We've done that a lot. The 5's cancel. 120 divided by 5 is 24. So that's probably the toughest problem of the day. You need to be able to do it. If you can do this problem, there's no other problem you won't be able to do. And if it's fractions that bother you, come and get help, okay? Now we're just going to sum a couple of things up here at the end. This is for those true and false statements, so if you're getting confused, remember first that you can get fractions for answers. Remember second that your variables can cancel out and leave you numbers that equal each other or don't. If that happens, just look at this little table at the end. If variables cancel out on both sides, remember, if you are left with a true statement like 9 equals 9, the answer is all real numbers. Okay, I'll write that out here again. All real numbers. If you're left with a false statement, you can draw the 0 with the line through it, which means no solution. And remember, you can get 0 for your answers. You can get fractions. I would rather you not get decimals. It's just getting more work for you. If you have any questions, let me know, and good luck.